And today I'm gonna present the session about building intelligent audio analytics with Amazon Bedrock and Amazon Transcribe. First of all, I would like to thanks Margaret for the invitation to be here presenting with the user groups. I think this kind of initiative, the AWS user groups, they are super important for our community, and I really like to be part of the community, contributing not only presenting but also participating. So thanks for putting that organizing this event. Just sorry, just about me, very quick. This is me on the left in the Community Day Mexico last month. Community Day, I don't know if everyone knows, but it's an event organized by people from community. It's not an event organized by AWS. So it's pretty cool because different from sales events, we have developers talking with developers, technical sessions, we can deep dive, share knowledge with others. It's amazing, this event. So I encourage you, everyone participating on these events. I also had the opportunity to meet with Jeff Parr over there. I really like his job. I'm a former AWS employee, so I know him back then about when he was posting blogs and this kind of stuff. More on the personal side, this is me on the right with my wife. Our first son that was born just last month. So yeah, I like to spend quite a time with my family, and also participating in community events, and working, of course, with AWS. Okay, this is our agenda for today. I'm gonna talk about audio data challenge, key components, study case that I have experience with, architecture blueprints, and some examples. Just one important note, I have been working with audio solutions for over 3 years right now, and with AI ML solutions over 5 years. And now I'm in both worlds, working with audio components, AI ML. So I've been working very close with contact centers, uh, and also working with autonomous agents to automate the speech-to-speech, not only for contact centers, but also for companies that want to develop an agent to be able to talk directly with the clients. So I have gone through a lot of stuff right now. I have some things that I can share that I see that works great, something that can be a challenge, and some opportunities to improve as well. So that's what I'm gonna share here. So the first thing, some audio data challenge that I observe. The first thing, we have nowadays a huge volume of audio content, uh, and it's only growing. We have podcasts, we have contact centers, and especially nowadays in the online world, where people tend to go into places, physical places, less than in the past. We are trying to solve things from our cell phones, from messaging applications, and of course through the cell phone. So we have this source of data. We have also data from um, podcasts, as I said. We have also videos, which we can just take only the audio parts. So this is all useful information that we can use. But it's also not that trivial. At least if I was 5 years back in the time, I would say that it wasn't that simple to extract insights from the audio files. But now with the Gen AI over there, I would say it's way more simple. So we have several solutions that are making the difference in the market. I will go through a couple of them just to explain what we can do with these solutions. And we don't need to be a AI ML expert. With a couple of developer experience, we can extract insights from these audio files. And we don't even need to go very deep, knowing about channel, audio formats, encoding, this kind of stuff. And of course, we need a analyze those data at scale. Imagine how many data we are ingesting. So we need a scalable solution. And of course, we need to compliance with privacy concerns like data, PII, for example, credit card information. We shouldn't be transcribing this information and using on not only in the internal but also for the external audience, and also observing the quality through observability practices in these solutions. So okay, with this challenge, we can transform into an opportunity. We just need the right tools for that. So basically, this is the toolkit that I would suggest for everyone starting in the audio analytics. This is the key components we have. We have LLM. Basically, the LLM is the brain that will understand the context, will generate intelligent response, will consume the audio in a plain text format that is generated from the speech-to-text. So the speech-to-text is responsible to get the audio file, an MP3 audio file, or a WAV file, for example, generate a plain text. And then LLM will receive the text and based on your prompt, you can extract a lot of information from this transcription. We will need also an efficient data storage, not only to store the data, the audio files, but also to store back the information that we are organizing with the LLM, structured data. We will need to store these data because we will need to query those data later. So having an efficient data storage is way important for the analytics part. And last but not least, we have also the orchestrator. The orchestrator is responsible to manage the workflow. So imagine we will have pipeline. Imagine we receive an audio file in a S3 bucket or any other storage, and then we will automatically trigger a pipeline to get this audio file, having a process, having a compute environment to process this audio file, generate the plain text, and then now I need an API call to send to Amazon Bedrock, for example. All these things will be done by our orchestrator. And this is also an important part. Here I have just to highlight us a use case that I worked on the past for one of the leading breeding tech companies. They have a very large call centers. Just for you to have an idea, in the Americas, they receive over 80,000 calls per month in the Americas call center. And they had so many manual steps, like a traditional contact center. Agents were receiving the call, they were asking questions to assess the customer concern or their question, and they were manually filling every information into the ERP, or in this case, Oracle. And they had so many problems with this kind of setup, like misclassifications, because agents can understand something that uh, sometimes cannot be correct, uh, or yeah, can be also in a situation like they are multitasking, talking with several customers at once, call at a call with one, chatting with two others in different sessions. They have several browser tabs open, and they are pretty busy. So they want to be fast. And with that pressure on them, maybe they are not collecting all the details that are important. So the documentation were not that good for the support when we needed to open a ticket, for example. So and the agents were spending quite a time on these manual steps. Our solution then, let's try to use Gen AI to automate that. So after we have finished the call, uh, in this case, Genesis is the dialing service we were using, but can be any other one. Uh, Genesis generate a MP3 file export from from that talk, and then you can ingest that MP3 audio file in any storage. Of course, we will need to set this pipeline to ingest the audio files, but Genesis will generate the audio file for you, and most of the dialing infrastructure service will do that part for you. Uh, I know this is a batch approach. It's not a streaming approach. This is a different situation, uh, but you can just batch calls at once in your storage. And once you finish uploading those files in a centralized storage, for example, you can start up parallel pipelines to extract the text from these audio files. Uh, and with this plain text, you can generate, for example, a summary for the call. You can assign a category based on predefined categories uh, for these calls. You can also try to get the agent behavior, customer feels, if the FAQ kind of questions that the questions that the client ask, and all this information is useful. You can create a knowledge base with the most popular questions, for example, and in the next time you are going to solve a similar problem, you can search on that knowledge base to see how we did on a previous situation. With that, we avoid misclassification, delays, and also we can improve documentation with automated transcription, summaries, and steps. I'm not saying that it's perfect. Of course, that's something that we will need to always improve through the prompt engineering, improving the model, but it's very consistent, the results. I mean, the AI is very capable to analyze several data at once. It's very scalable. And some of the benefits that we observed after the implementation, and that's were our goals when we started. So we reduced the call handling time. Uh, when we started the project in the past, they had an average call length 10 minutes, and we understand that the benchmark in the market for similar companies are 7 minutes and a half. So this 2 minutes and a half over the average. It's very cost expensive. It costs money talking with an agent. So being faster means saving money in that situation. So we wanted to reduce call handling time, especially in a situation where we receive over 80,000 calls in a month. Imagine the in that scenario. So we can also enhance the accuracy. Uh, the agents can make some mistakes, but the AI can suggest a correction. For example, uh, one thing that we did in this situation, we are not overriding the agent notes or the categories, but we were appending a suggestion, and then we were evaluating based on that suggestion from the AI. So we can see if we are being accurate for accountability stuff. We can also be efficient in data processing at once, uh, like processing so many audio files at once. And we are capturing now information that we even know that exists because people were not listening to the audio calls from the contact center after it ends. So we are extracting more from that data. We also improve the agent performance visibility about if the customer feels his problem seems to be solved. Different than a IVR that asks you like, hey, did you like that agent support? Now we are analyzing automatically from the call if the agent performed well or not. It's not that binary. It's just for a means to explain. Okay, and of course, the one of the main goals of most of the companies is to lower the operational costs and reducing the call handling time, avoiding receiving so many calls, having this information exposed, of course, in an anonymized way to external audience. You are receiving less calls, so you can optimize the operational costs as well. I've tried several solutions in these few years that I have been playing with the solutions. So for general LLM, I tested the most known LLMs like Anthropic. I tested several from cloud like Sonnet, Opus, Haiku. I also tested Amazon Nova, Meta, GPT. I can share some information about them. I will share in a bit. But for now, I also want to talk about speech to text solution. I tested Amazon Transcribe, JeepGran, and OpenAI Whisper. One thing that probably we'll see here, Amazon Transcribe, it's a AWS solution. DeepGran, it's an AWS partner, and OpenAI Whisper, it's an open source tool. So you can download from GitHub and you can deploy it in your local machine. Or you can also consume through an API from Hugging Face, for example. There are several ways to deploy that. Some of my thoughts about these speech-to-text solutions. Amazon Transcribe integrates pretty well with AWS workloads, especially when you have everything there. But it's not only the technical part that matters. Also from the uh, bureaucracy, commercial part also matters. For example, there are large companies. Uh, they have a procurement process that maybe take more than 2 months, and after that, they have a security process that will take more 2 months to evaluate if a tool can be used. And maybe that company is just trying to be fast. And in these scenarios, Amazon Transcribe is pretty well. The downside, at least for me, it's expensive, and the performance is not the best. I'm not saying it's a bad solution. I'm saying that there are pros and cons. DeepGram, at least for me, it's one of the best options that we have in the market. They are specialized on this kind of solutions. Their documentation is pretty decent. Amazon Transcribe, I found several things outdated and it annoyed me a lot. So one point towards DeepGram in that scenario, it's very easy to set up. You can use through API. You can also do local deployments to reduce the latency. Those first two solutions, they are managed solutions, let's say like this way. So you don't, for example, if you need a built-in feature like reduce noise, redactness information, you have already built in. And what about OpenAI Whisper? This is a self-hosted solution. Or you can also consume from other service that deployed that solution and are offering you as a service. But in general, OpenAI Whisper, it's a pretty good engine for speech to tests. Their V3 large model, it's amazing. The downside, you don't have so much built-in features. For example, when we are gonna, you may face some hallucinations, these kind of things, and it's not easy to solve and go through these scenarios. I am talking about from my own experience. Data storage, we have Amazon S3, pretty decent. It's cost effective. I also use Confluence. It's good for internal usage. If you have every employee that is signed in Confluence, you can open links, you can open the audio files or any other information directly from Confluence without going to a S3 bucket to open the files. And for orchestrated, there are many flavors, but the flavors that I played in the past a lot, Lambda functions, containers, ECS, AKS. There are a small difference between them. Containers, they are long running, and Lambda it's a function as a service. So there are different limits. Lambda has a hard limit of 15 minutes. So if you have a kind of service that you need a solution that keeps running, the virtual machine, probably will need to go to containers. But if you are only getting the transcription, generating some key information from the transcription with the LM, only API calls, there's no reason to go with containers, at least in my opinion. So it depends from use case to use case. Okay, so some tips, general tips for you when selecting these solutions. And I'm summarizing a lot here. We have to discuss if anyone wants by the end. But my general advice on LLM, think not only in the complexity, but also in budget. These are the two most important weights that you need to take into consideration. And don't underestimate the complexity. Maybe you have a very complex scenario, several tool usage, a very large prompt, and you are with a lightweight model. It can hallucinate. So you need to think about these two weights. I think they are the key important part when deciding the LM you are gonna go with. The speech to text solution that will transform the audio into text. You need to evaluate the accuracy, latency, and of course, language support. Efficient data storage, a solution that offers you a tiered storage like S3 has Glacier Deep Archive. You can optimize costs with tiered storage solutions. An orchestrator, uh, that's up to you. And my solution, think on your team expertise and leverage your strengths. Do not overcomplicate. So I'm fine if you think that it gonna work in Lambda, so go on with Lambda. If you need ECS, because the reason ABC, so go with ECS. Okay, I understand everything. Where should I start? The first thing that I typically recommend to people, uh, get your data together. Uh, so imagine you need to have a central repository for this data. In this case, can be S3, as I said previously. So what makes difference your application? It's your internal data. They are very powerful. That's what gonna make an advantage, competitive advantage when comparing to your competitors. So it's pretty important that you upload your audio files to Amazon S3 bucket, and can be audios, like I said, from contact center, podcasts, uh, or any other sources, but you need to have this data. And I suggest at least a good amount. And after that, you can make more with your data. This is a sample blueprint architecture. So here on the left, we have Genesis. Genesis is uh, generating the audio files. We are uploading everything to S3. And when we upload the audio to S3 bucket, automatically we'll put these files into Amazon Q SQS service. And then we are gonna trigger the pipeline. The first thing, we are gonna to use Amazon Transcribe to generate the plain text. After that, we'll call Amazon Bedrock with a prompt doing like, hey, I wanted the key information. I don't care like if the user or the agent say, hello, how are you doing? These kind of things. I wanted the key information. I want to format the data in a structured way with useful information. So just a sample from Transcribe, and I trimmed here to fit here. But when we send an audio file, we are gonna receive a result like this on the, take a look on the transcript. You're gonna receive the entire transcript. And of course, I have anonymized here the company name and all other information. And then with that information, that plain text, we can generate a summary. So now from 10,000 words, I have only 100 words. So it's a summary. It's pretty good, pretty decent. We have the ticket number that the user is mentioning during the call, the product, the performance of the agent, if the user talked about serial number, fail code, account number, any other information we'll be able to get. But if the user don't talk about this information, we are not gonna get it. Other useful information like primary resolution. What do we suggest to these clients? What is this call about? It's a product issue, it's a complaining, or any other kind of stuff. We have also resolution status, if it wasn't solved or it was solved, and the primary issue. Some of the FAQ also, what the questions the client asked to the agent, and we are also aggregating all these questions into this JSON file, and we are storing back into S3, Amazon S3. We also have other information. This is a pretty big file because we are aggregating several information here, like the code, category that this issue that should belong to. And here I'm showing to you how we can do more with the information. Okay, I have the JSON files back to S3, all these files that I showed to you. So what I can ask to my knowledge base right now, I can ask, hey, do we have standby calls? Yes. Here we are using Amazon Q Business to ask these questions using knowledge base and as data source Amazon S3, but you can also build your own custom application using any RAG, any custom solution for chatbots. We can also ask for unresolved calls, customer sentiments, and he's going to show you the samples where he's taking this information from. We can ask information about specific customers here, like Emily Smith, and we can also make a lot of, we can do way more with this kind of information. I will open for questions. I know we have very few minutes for Q&A, but I'm happy to chat. Even though if we need to start the Scott session, I can be here a little more to answering the questions in the chat. Thank you very much. Here is my professional social media. If anyone wants to connect, keep connected. Thank you very much.
Thank you, Vinny.
Vinny, thanks for a great presentation, man.
Hey, thank you, Brian. I'm glad that you were able to participate.
Absolutely. Thank you, Margaret, for letting me in.
Thanks, Vinny. I have a question, and it's related to your speech to text conversation. So how do you know, I mean, you use some tools and you decide, okay, this one works better, but there will be still hallucinations, right? Like, how would you clean that or overcome those kind of situations? Or how do you know, like, is it how much accurate?
Okay, some of these solutions like Amazon Transcribe and DeepGram, as I said, they are managed and they provide you with accuracy rates. They are very good solutions, especially when we have good quality calls. Of course, for situations where we have poor connections or the client is speaking far away from his cell phone, the audio quality is going to be poor. And for these situations, the quality of the confidence can be very low. My suggestion for those scenarios, try to take a look at these specific calls and put on a different pipeline to evaluate more carefully if you can retrieve useful information, even though the accuracy is not that good. Because to be honest, you don't need to have 100% accuracy, in my opinion. There are so many things during a call with an agent that doesn't matter. For example, imagine you are talking with an agent and, hey, your mother, I don't know, any other person come talking to you. And in the middle of the call, suddenly you have, hey, hello, man. How are you doing today? This information doesn't matter. We need the core. And even though if we have not very good accuracy, and by very good I'm meaning 99%, if we have a poor, and by poor I'm saying 7%, we can maybe extract useful information, the core at least. Now if we have 40%, 30%, that may be a good candidate to not consider in our pipeline.
I see. Yeah. Okay. I mean, that's a good point. Yeah.